Good day, we are Group 4 and this is our case study report titled Risk Assessment of Smart Substation Relay Protection System based on Markov Model and Risk Transfer Network. So, I am Carl Angelica de Ramos and I am here to discuss about our introduction. So, substations are considered as the unsung heroes of the power grid. They are the facilities where electrical energy is transformed from high voltage to low voltage or the reverse. Without substation, consumers would not be able to get the electricity needed to power their houses, businesses, and even our simple devices. Nowadays, smart substations are becoming increasingly common as the power grid transitions to a more digitalized and intercommed systems. These substations offer a number of advantages, such as improved efficiency, improved reliability, and improved security. However, they also pose new challenges for adequate protection and maintenance. So, importance of maintenance. The importance of maintenance of a substation cannot be overstated. Substations are critical pieces of infrastructure that are essential for the delivery of electricity to homes, businesses, as previously mentioned. And to list them, there are a number of reasons why substation maintenance is important. First, it can help to prevent equipment failures. When equipment is not properly maintained, it can wear down and eventually fail. This can lead to power outages, which can have a significant impact on businesses and residents. The second, the second one is it can help to improve the efficiency of substations. By identifying and fixing problems early on, help to improve uh, the substations and to avoid costly repairs and downtime. And lastly is it can help to improve the safety of substations. By keeping the equipment in good working order, substation operations can reduce the risk of accidents and injuries. And since substations become complex eventually, it is also expensive to build and maintain. As an aftermath, it is important to have a comprehensive maintenance plan in place to ensure that the substation operators can help to protect the public, save money, and extend the life of their equipment. In the given article for our case study, they discuss the importance of developing a relay protection system that considers the security and stability of smart substations. Relay protection is a critical system that is used to detect and isolate faults in power lines. Because in a traditional substation, relay protection is relatively very simple. However, in smart substation, they are much more complex and they use a variety of new technologies. This complexity makes it more difficult to design and implement effective relay protection systems. Once the risks have been identified and prioritized, risk mitigation measures can be implemented to reduce the likelihood and impact of potential failures, and these topics will be further discussed in the next sections of our report. So, essentially, to end my report, the best risk mitigation measure for a particular risk will depend on the specific risk and the resources available. It is important to evaluate all of the options and choose the measure that is most likely to be effective. Thank you.
As for the summary of our case study, the complexity of smart substations make it difficult to design and implement effective relay protection systems. The use of new technologies in smart substation can create new vulnerabilities that can be exploited by attackers. The increasing interconnectedness of smart substations make them more susceptible to cascading failures. These problems can lead to a number of serious consequences, including power outage, damaged equipment, injuries or death, and financial losses. It is crucial to create a relay protection system taking into account the real-time online operation, status evaluation, and the risk assessment of that substation in order to successfully ensure a secure and stable operation of a smart substation. In this study, a Markov model-based operating state assessment um, approach is initially proposed for each device in the Relay Protection System or RPS, based on action data, defect data, and network message information of the system protection device or PD. The risk transfer network is then used to conduct the risk assessment of RPS in the smart substation. Finally, a case study of typical 220 kV substation is presented to thoroughly confirm the feasibility and effectiveness of the suggested strategy. The case study demonstrated that the provided strategy may improve the maintenance schedule for the smart substation.
Analysis. Smart substations include different devices such as pass protection device, line PD, main transformer PD, network switch, merging unit, and intelligent terminal device. These devices are subjected to fault testing and analysis, and in this paper, they use the Markov model-based operation state evaluation method. This method prepares the relay protection system, which is then assessed using the risk transfer network. By simulating the Markov model over a period of time, the method can evaluate the system's behavior and performance. It can provide insights into the system's availability, reliability, and maintenance requirements under different operating conditions. This paper has listed 2 reasons for failure of protection devices. So this has been the guideline for creating the Markov model for the operation of protection devices. So the first one is that the device is abnormal and was not fixed in timely manner, resulting in failure of the device function. The second is that the unexpected failure, where it directly causes the failure of the device function. The primary role of a protection device is to identify and address abnormal conditions or faults within the system, taking necessary measures to minimize their impact. These measures can involve isolating faulty sections, activating alternative protection elements, or triggering warning signals. When a protection device is unable to fulfill its function due to an abnormal state, it undermines the system's capacity to respond to appropriate faults and abnormal conditions. So, this can also lead to prolonged periods of system inactivity, equipment harm, safety risk, or even chain reaction of failures throughout the whole system. So, to prevent these failures, it is crucial to implement a proactive maintenance and monitoring program for protection devices. So, to fully grasp and understand this, or how we deal with this, there should be an understanding of factors that affect the efficient and effective operation of protection devices. So, in this case study, there are 4 factors that are discussed. First is the hardware. The quality, reliability, and compatibility of the hardware components directly affect the performance of the protection devices. High quality hardware ensures accurate sensing, reliable operation, and swift response to faults or abnormal conditions. Next, software. The software includes algorithms, logic, and settings that govern the device operation. coordination, and decision-making capabilities. Properly configured and up-to-date software ensures accurate fault detection, optimal coordination with other devices, and appropriate response actions. Next, external loop. The external loop refers to the overall electrical network or system in which the protection device are installed. Factors such as fault levels, load variations, voltage fluctuations, and system impedance influence the behavior and performance of the protection devices. Communication communication, reliable communication networks and protocols are essential for accurate information exchange and timely coordination among protection devices. Robust communication systems enable efficient monitoring, control, and fault analysis, enhancing the overall effectiveness of protection devices. It should be noted that these parameters are interrelated to each other, and their combined impact determines the overall efficiency of the protective device operation.
So next is the recommendations. The Markov model, a mathematical framework, is utilized to analyze the behavior and performance of system components. It considers the various states these components can be in and calculates the probabilities of transitioning between them. By applying the Markov model, the proposed method can assess the associated risk in some smart substation relay protection system. In order to enhance the effectiveness of the proposed method, it is recommended to establish a complete monitoring statistical database. This database would collect and store data on the operation state of the secondary system, including the relay protection system. Analyzing the relevant operational data enables a more accurate assessment of the system state and a more detailed consideration of operational risk. Future research directions include improving and establishing the Markov model specifically for hidden faults in the protection system. Hidden faults are risks that are not easily detectable but can still have significant consequences. By developing a refined Markov model that can capture such hidden faults, the risk assessment process can be further enhanced. Furthermore, it is suggested to conduct additional studies on risk assessment for smart substation relay protection system, which involves the utilization of the Markov model and risk transfer network. Exploring alternative approaches to risk assessment will contribute to improving the accuracy and reliability of assessment conducted in smart substations. Thank you.
So for the conclusion, in conclusion, the risk assessment of smart substation relay protection system using Markov model and risk transfer network provides a solid framework for assessing the risk associated with smart substation. So it enables a holistic understanding of system reliability, vulnerability, and interdependencies among system components by leveraging the Markov model and risk transfer network. So this approach can guide decision-making processes, allowing stakeholders to allocate resources more efficiently and implement effective risk mitigation strategies to ensure smart substation operate reliably and securely. So by understanding the risk assessment of smart substation relay protection system based on Markov model and risk transfer network, it is important as it allows stakeholders to enhance and develop effective risk mitigation strategies. These comply with regulations and foster continuous improvement in the operation and management of smart substation. Furthermore, the incorporation of a risk transfer network analysis by taking into account an interdependence of various components within the smart substation. So this network-based approach allows for the evaluation of cascading effects and dependencies among system elements, so which is critical for understanding risk propagation throughout the system. Thank you po.